Hello and welcome everybody to the ABSIX webinar on new food safety solutions using the new Exigent Expert ultraLC 100 system combined with the new QTRAP 4500 LC-MS system. Before starting today's webinar, I would like to introduce myself. My name is André Schreiber. I'm working in the technical marketing group of ABSIX, and I'm responsible for method and application development for new food safety applications. Let me give you a quick outline of today's presentation. I would like to talk about the new Exigent Expert ultraLC 100 system, which is an ultra high-performance liquid chromatography system which was specifically designed to use with ABSIX MS instruments. It has a maximum pressure of up to 18,000 psi, and it can be operated at a flow rate of up to 5 ml per minute. It also comes with a patented injector valve to increase the lifetime of your HPLC columns, and also it can be used with programmable needle wash, which was designed to reduce carryover. I also would like to talk about the new ABSIX QTRAP 4500 system, which offers slightly increased sensitivity and increased speed over the legendary API 4000 and 4000 QTRAP system. And it provides higher sensitivity and faster QTRAP scanning in comparison to the older QTRAP instrument. Also, we did some work on the ion path to allow you to scan a larger mass range while having excellent ion confinement, especially in the lower mass range. And I would like to mix that up with a little bit of application data. I would like to show you some data on perfluorinated compounds analyzed in drinking water, some pesticide data, and some data on acrylamide and identification of unknown natural toxins. On this slide you can see a picture photo of the new HPLC system and also of the new QTRAP instrument. This combination offers a highly sensitive and reliable LC-MS solution, which is great for quantitation at low levels, and also with additional QTRAP functionality it allows to acquire highly sensitive and fast full-scan MS data, which can be used for compound identification based on MS library searching. And this new LC, together with the new mass spectrometer and other ABSIX products, we offer a comprehensive solution for food safety analysis. Let me give you a little bit idea about the technology behind the ABSIX QTRAP 4500 system. Our R&D scientist engineered that system based on leading technology. We borrowed a couple of hardware components from our 4000 system, like the Turbo-V ion source, the curtain gas interface, and the Q0 quadrupole, which allows us to maintain the robustness and ruggedness of the 4000 system. And also this way we can efficiently focus ions at the entrance of the vacuum system. We combined that with a couple of hardware features of the 5500 systems, which especially allows us to speed up the time of analysis, which allows us to reduce the MM cycle times and to speed up QTRAP scanning experiment. And as a final part, our R&D scientists optimized the driver frequency of the ion path, which allows us to use the instrument in comparison to the 5500 with an extended mass range while maintaining low mass ion confinement. Let me show you a couple of examples about key features of the instrument, and let me start with sensitivity. In the following example, you see the analysis of perfluorinated compounds in drinking water, a very important topic to environmental scientists. Here we detect perfluorinated octane sulfate at low parts per trillion levels. On the left side, you see an injection of 2 nanogram per liter of PFAS, and on the right side, you see the exact same concentration analyzed on the 4500 system. Since we had to go to very low levels to match environmental relevant concentrations, we inject a large volume into the LC system, and we operated the instrument at a higher flow rate of 1 ml per minute. If you compare both chromatograms, you can see that the 4500 has slightly higher sensitivity and slightly better signal to noise than the 4000 system. And also due to the optimized speed of the instrument, we gain excellent reproducibility with a percent CV of 2.5 at that very low level concentration. Here you can see another example which is showcasing the speed and performance characteristics of the instrument. We developed a method for comprehensive pesticide screening, combining shortest MRM cycle times, the scheduled MRM algorithm, and fast polarity switching. We look for a total of approximately 500 MRM transitions with a total cycle time of only 0.7 seconds. And we cover a large panel of pesticides, some of them ionizing in positive polarity, some of them in negative polarity, that we can screen for pesticides having different chemical properties in a single analysis. Just to highlight the sensitivity and reproducibility using that method, I just grabbed a couple of example compounds in positive ion mode, carbendazime, which is eluting at 4.1 minutes in a more busier part of the chromatogram, and at a very similar retention time, propoxycarbazone in negative polarity. You see the injection on the screen on 1 nanogram per milliliter, so 10 times below the typical detection limits requested in food analysis. And you can also see, due to our capabilities to run MRM transitions and do polarity switching really fast, our reproducibility is excellent with percent CV way below 5%. Here's one example of a real sample. We extracted a lemon sample using a catcher's procedure using Restec catcher's kits, and the extract was diluted 5 times before injection to minimize any possible matrix effects and ion suppression. The analysis in positive and negative polarity identified a handful of pesticides, as you can see on the screen. And for data processing, we used the multi-component query in our Multicorn software, which is automatically flagging compounds being identified in the sample above a concentration of 5 microgram per kilogram, and also if the MRM ratio is positive. Here is another example where we analyzed orange juice samples for different pesticides, and I'm just showing the positive polarity example here, but 2 samples instead of that. We had 2 orange juice samples which have been analyzed after centrifugation and direct injection after dilution, and we found 13 or 67 nanogram per milliliter of carbendazime in these 2 samples, and again, confirmation using the ion ratio was positive. Here's a screenshot of the software tool I was using for analysis. We quantified all of our data inside of Multiquant, and then we developed a very specific query called multi-component, which automatically does all the calculation being relevant for food residue analysis. It will automatically flag compounds above a specific maximum residue level, which can be specified by the user, which also can be compound specific. And automatically the software is calculating MRM ratios and comparing MRM ratios of unknown samples against standard injections, and it will automatically report compounds if the MRM ratio is matching standard injections. And here on the screen you can see 3 examples I was highlighting. The 2 orange juice samples had a concentration above the 5 parts per billion I was specifying, and the MRM ratio identification was positive. While the 1 clementine sample we analyzed also had a positive MRM ratio, but here the concentration was below the 5 parts per billion. To further increase the confidence of identification of carbendazime in orange juice, we activated special QTRAP functionality. We performed high sensitivity, fast MS-MS full scan experiments. We scanned the QTRAP mass range with a scan speed of 10,000 Daltons per second. And on top of that, we activated a feature which is called collision energy spread, which is performing MS-MS using several collision energies, typically resulting in more characteristic MS-MS spectra. Since these MS-MS spectra contain way more information than the traditional MRM ratio analysis only, we can search the MS spectra against a mass spectra library, and the library fit will tell us how confident we can be that the identified compound is indeed in the sample. And using library fit values here way above 90%, we are very, very confident that both orange juice samples were contaminated with carbendazim. As another feature of the instrument, I would like to talk about the mass range capabilities. The total mass range which can be analyzed with the instrument is from 5 to 2000 Dalton. And the upper mass range can be very important for new and emerging applications in food testing laboratories. More and more compounds being interesting for food chemists are in the higher mass range, like for instance a couple of natural toxins are produced by algae. And here's one example where we combine precursor ion scanning with enhanced product ion scanning to identify unknown natural toxins in some shellfish samples. And the enhanced product ion scan you can see at the bottom was containing a doubly charged ion of a precursor ion mass of a little bit more than 1300. Since we also worked on our drive frequency of the ion path and it was optimized to 940 kilohertz, we also have very excellent ion confinement, which is important for the low mass range. An example showing that is presented here on the following slide. Acrylamide, a very low molecular weight and very polar analyte, is relevant for food scientists. Acrylamide can be formed when frying starchy food like potatoes, for instance, at very high temperatures. Acrylamide is very challenging to analyze because HPLC separation is very difficult due to its high polarity, but also the sensitivity of the mass spectrometer must be controlled properly through the ion path design. Here we have an example to detect acrylamide using LC-MS-MS at sub-parts per billion detection limit using the new QTRAP 4500 system. And this allows us to simplify our sample preparation and also to dilute our samples extensively while still maintaining sufficient sensitivity. To give you some idea about the method performance criteria, you have here an example screenshot showing the lower points of our calibration line of acrylamide, highlighting the sensitivity and reproducibility of the method. And at the bottom, you see the calibration lines starting from 0.1 all the way up to 100 nanogram per milliliter, so we could definitely quantify the compound with high reproducibility over 4 orders of magnitude. Here's one example of some real samples we tested for acrylamide using the developed method. On the top right, you see some ground coffee, where we found 130 microgram per kilogram. And at the bottom, you have 2 different potato chip samples, where we also found acrylamide in the 200 to 500 microgram per kilogram range. And this was done after very crude extraction. We extracted 1 gram of sample with 10 milliliter of water, and then we diluted each sample extract by a factor of 10 to minimize possible ion suppression effect, and that became possible due to the sensitivity of the mass spectrometer. With this, I'm at the end of my presentation. I would like to summarize a little bit. I was introducing to you the new Exigent Expert ultraLC 100 system, which is a newly designed and specifically designed UHPLC system for use with the AB-SCIEX MS-MS mass spectrometers. I also was talking about the new AB-SCIEX QTRAP 4500 system, which was engineered using leading technologies. We increased sensitivity and speed over the legendary API 4000 and 4000 QTRAP system. We could introduce higher sensitivity and faster QTRAP scanning capabilities by including parts of the 5500 system into that new mass spectrometer. And by optimizing the frequency of the ion path, we were able to extend the mass range while maintaining low mass ion confinement. And I was combining that with a couple of example application data on perfluorinated compounds, on pesticides, on acrylamides, and also on unknown natural toxins. With this, I would like to say thank you for attending today's webinar and for listening. I would like to say once more that the new ekspert ultraLC system in combination with the triple quad and QTRAP technology of AB-SciX and other products like our ID Quant kit and software solutions are great solutions for food safety analysis. Thank you for listening.